Alright guys, so now we've talked about function composition for a bit. Now we want to talk about inverse functions for a bit. And the way we want to start talking about inverse functions is this idea that it's often really important to go backwards, right? So when we have like 5 times x equals to 3, the thing we do is we look at x times 5 and we say, well, I really want x alone. And so instead of multiplying by 5, I'm going to divide by 5 on both sides. And so I'm going to get x equals to 3/5. Right, and this idea of dividing by 5 is undoing. So we undo our multiplication by 5. That's like what we did, right? And the idea of an inverse function is sometimes we have more complicated things, right? You might have f of x equaling, 20x plus 13, right? Something a little more nasty, right? And maybe we know that some number here, maybe we know that like f of x, the output for f of x was somehow 40, and we wanted to know what was x, right? So if we know the output, we want to find the input. So the idea of an inverse function is how do you undo a function, right? How do we undo a function, right? And just like with multiplication here, the way to undo multiplication is division, and division, like we've kind of talked about in class, right? Dividing by 5 is the same thing as multiplying by 1/5, right? So it's like multiplication and division are really kind of the same thing. So to undo multiplication, you use multiplication. To undo a function, you can also use a function. Alright, so previously, we would probably set this equal to 40 and then solve for x. Right? But another way that we can do things is to just use a function. So an example we already know from this class, in fact, if I have x squared equal to, let's say, 64, right? Well, if I'm trying to solve for x here, I would say x equals plus or minus the square root of 64. I just wrote 4. Of 64. Well, what did I really do in the middle here, right? What happens in this middle gap is that I really took a square root of x, and I took the square root of 64, right? I did this middle bit, and this middle bit here is really using an inverse on both sides, right? The opposite of x squared, right? If I have f of x equals x squared, right? If I know the output is 16, the input better have been 4 because that's the square root of 16. So here, the inverse of f of x, which we're going to denote with this f -1 of x, it's kind of just how we denote it, is going to be the square root of x, right? The inverse of x squared is the square root of x. And we want to be able to find these inverses, these special functions, that find the value of x once you know x is equal to a number for just general functions. And so there's going to be a couple rules that happen, and we maybe just want to highlight the main rule here. This is like the rule that rules all rules, right? Like the one ring. So the main rule for inverse functions is that the outputs and inputs switch. This is like if you understand to find an inverse, the outputs and the inputs switch, everything's going to be aligned here, right? This is the main reason. How are we going to do this, right? So if we go back to our first example, right, our outputs and our inputs are going to switch because we want a function, right? It's a magical function, f inverse of x, that we can compose on both sides, f inverse of x. Now on this side, we're just going to be left with what we started with just x. Right? So let me get a new sheet of paper, and we can talk about that.